So I want to welcome you. I'm Dr. Rusty Lowe. I am the Science Globe Mission Mosquito, and I'm very, very happy to welcome all of you today and many, many new faces being part of this Zoominar. That's also very exciting for us. Because we have so many new people, I would just like to let you know that while this is kind of a it's a talk as opposed to a discussion, but we'd like to keep it as informal as possible. So anytime you have questions, please just type in your messages, and one of us, either Dorian, who is our campaign lead educator, or Cassie or myself, will try and answer any questions that you have as they come up. They don't have to be directly related to what's being discussed. Anything that's in the realm of mosquitoes and vector-borne disease is okay to talk about. And today we have a very exciting program for you, I think, because we have a guest speaker. And if you want to go to the next slide, Cassie, we'll just get going here. Our guest speaker today is Peder Nelson. He is the science lead for Land Cover, the Globe Observer land cover tool on the app. And Peder and I are very excited to be working together because we both understand the importance of the environment, and especially the vegetated and unvegetated, the landscape environment, and how it relates to where we find mosquitoes. And so he's going to give us a lot of pointers on that, and I'm hoping at the end of this presentation you'll see how it would be really great when you do your mosquito observations if you'd also do a land cover observation as well. And hopefully you'll get so excited about what he has to say that you'll be hoping to do that, be willing to do that. So, but first I'm going to do a little introduction about where we're going with Mission Mosquito. So let's take the next slide, Cassie. And for those of you who are new, I thought it would be good just to tell you a little bit about Globe. It's an app. It's part of the Globe Observer app. You can see it there in the middle of the screen. And basically what the app does is it takes you step by step through looking to find standing water, either in a container or in a natural space, and then taking a sample of the water, looking at to see if there are mosquito larvae, and how to recognize the mosquito larvae is all in the different steps of the app, so it's very easy to do. And then if you are so inclined, you can also take that sample and then use a clip-on microscope and use that to identify to see whether or not the larva that you found is one of the taxa that we have in our app that could be potential vectors for disease. And so most mosquitoes, there's 3,500 different species of mosquitoes. Most of those mosquitoes are not going to be vectors of disease. And in many states, for instance, I know in Maryland, there are 50 different kinds of mosquitoes. So don't be upset or alarmed. Be very, very happy if the larva that you find is not one of the ones that we're collecting. We still want the data on the mosquito that you found. So that is what we're doing with the app. And then in the last picture, the woman there with the tire is demonstrating in sort of a random way the last step in the app. Because if you do find a container that has mosquitoes in it, we're asking you to please eliminate that habitat by dumping out the water and making it unavailable to mosquito mamas. And that is actually a very concrete thing you can do to reduce disease in your community. Okay, next one, please. So I just put this map in because it shows where we are expecting to see mosquitoes. And when we started this webinar series back in January, we were just beginning to have mosquitoes in the far point of Florida and the southern parts of California. But as you see now, by late May, in the United States at least, we now have mosquitoes in every part of this country, all the way up through the temperate zones. Of course, if you are in a tropical area, you probably have had mosquitoes this whole time. So it's just a little bit different for you guys. Okay, let's take the next slide and I will show you where we are so far. So as you can see, these are the places where we have reports of mosquito data. And a couple months ago, Cassie showed you how to actually find and retrieve this data on the Globe site. So if you're interested in doing that, you can find the webinar that has that information for you. But what we see here is there are over 12,000 different places, different sites where we have found mosquitoes. And in among those sites, we may have many different repeats. So that's very, very interesting. So we're really coming along with our citizen science work with mosquitoes. Taking the next slide, please. We're going to talk a little bit about something exciting. This is a little preview, but June 1st is coming up very quickly, and we're going to be launching something which is called Go on a Trail. So so while we try to make this a very international webinar, I think this is really appropriate to talk about here just for our North American counterparts, because it is a little bit exciting. The Lewis and Clark National Historic Trail has partnered with Globe Observer, and we have this campaign called Go on a Trail, and it's going to be going on throughout the summer, and it's going to be a way that people who are visiting some of the national parks can actually use the Globe Observer app as a way to describe what they're seeing, and it will also allow us to collect more data that we need, that the National Park Service wants, and that NASA needs. So it's a pretty exciting kind of effort, and I'm hoping that Peder, who is a real lead on this project, will talk just a little bit more about that. Next one. So this is a map. Peder, you might have brought a better map with you. I just grabbed this one. But just for those of you who don't know, that the Lewis and Clark was one of the very first scientific expeditions. Many scientists recognize it as one of the very first scientific expeditions. Thank you. I'm going to slow down here. The very first expedition ever arranged. It went from 1804 to 1806. And they were, Lewis and Clark were both tasked with describing a part of the world that was unknown to the government that was in Washington, D.C. Of course, it had its own inhabitants, but they were interested in describing this part of land that had been acquired because of Louisiana Purchase in 1803. So if we go to the next slide, this is why this is really exciting for me, because, you know, Lewis and Clark were essentially doing citizen science in the sense that they were not scientists. They were in government service, but they were asked by the president to describe the physical and biological characteristics they saw along the trail, including soil, vegetations, animal, mineralogy, metals, weather, phenology, all of these things. And as you know, if you've looked at the Globe Observer tool we have, we are able to describe phenology using mosquitoes and vegetation, and weather using our app. So there is a lot of similarities there. But instead of having to draw maps, you know, our app automatically comes up with the GPS coordinates and gives you a map. And instead of having to draw in written notes what the vegetation is like, you can simply take a picture and describe it in the Land Cover app. And so there is a real great parallel between what these people were doing over 200 years ago and what we're doing today. And of course, it allows us to have that baseline of what the world was like before industrial civilization began to put its footprint on the landscape. Okay, next one. So fantastic. So this this is just an example of some of the kinds of things that we find in those wonderful diaries that were created by Lewis and Clark. And I don't want to have to sit and read this to you, but you can read it to yourself. But you can see that he's describing what the grass is like, how high it is, what the soil is like, that they were troubled terribly by the mosquitoes and they weren't able to sleep if they weren't able to get under their, they didn't have mosquito nets, but they had kind of like a piece of duck that they would put over like a hoop, and they would be able to sleep under that. And they were saying how important it was for them to get their sleep, that the mosquitoes were a huge problem. And so on this day, today's May 29th, right? So Clark wrote, mosquitoes are very bad. So one of the things that people who are participating and Go on the Trail can say is they can go to a place and say, would this be a place where mosquitoes were very bad? Because at this time, you know, the Missouri River was a very different kind of thing than it is today. Today, the Missouri River has a bunch of dams. It's been channelized. There's a lot of flood control systems in it. And so you don't have the same kind of dynamic wetlands along it that we had in the past. And so those are some of the things that you can notice and report using the Mosquito Habitat Mapper. Next one, please. They also described, you know, what the grasses were like, what the plains were. And here's another small snippet from one of Lewis's journals, where he describes that the land is level, fertile, and the grass is open and beautiful as far as the eye can see. Today, I just have a short map here at the bottom that shows that where we used to have prairie, which you see above here, and we have the short grass prairie, the mixed prairie, and the tall grass prairie, that these places have now all been, the prairie is now been removed. They say that today we have less than 1% of the tall grass prairie that we had 200 years ago. And we do have some places where we are conserving this kind of vegetation, but in many places, as you can see, we have crop lands that are prairie, that are replacing these prairie grasses. The brown is, in this picture, is wheat, the yellow is corn, and the green is soybeans. So you can get some idea of what has happened to those grasslands. So it's really important for us to be able to talk about and describe what we see today, and it's very informative for us to compare that with observations of those explorers that were also taking scientific measurements. So that's one of the things that's going to make Go on a Trail very exciting. So thank you so much. And next slide, Cassie. So now I would like to, it is my great pleasure to introduce Peder Nelson, the lead for Land Cover. And I'd like to think of him as my partner in crime. And I'm just going to let him go and tell you more about how your interest in mosquitoes and the data that you collect can really be enhanced by also looking at land cover. So Peder, I'm going to be quiet now, and I'm going to turn it over to you.
Thank you very much, Rusty. I really appreciate the deep, informative background about what we're trying to do in terms of making a science product as we can, and that we can actually pass information from one generation to the next generation. And how do we do that is a big question. And to me, this is kind of the again, another exciting part about this program is that we're all working together to understand the world that we live in. And sometimes it's, a challenge because we don't know what was there before us. You know, we come into this world and other people have created it. And so having journals or documentation like what Lewis and Clark have provided us gives us a sense and a way that we can actually go back and look at what has been happening on Earth. What are these changes? Is the climate really changing, or is it weather that's happening? These are all important concepts that I think Lewis and Clark and the idea of documenting our landscape is really important. So next slide, please. Oh, hold on. My computer just left up there. Okay. So today I want to talk, kind of want to go over and kind of review Globe Observer and kind of how these different protocols that have been created actually can work together to give us a better understanding. And so even though that we have these individual tools, mosquito habitat in particular for this group, but there are other tools that might actually help to describe the mosquito habitat or the area that we're looking at, whether it be the clouds that might be influenced by the landscape or the terrain that we're in, or actually measuring out trees, or doing the photographic evidence of what the land cover is like today. All of these go together and make it easier for us to actually be able to share information together and to make something that is long term. And so I want to talk about that. I want to talk about how mosquitoes, habitat, and satellite measurements actually go together. In particular, I want to hear from you guys about what is land cover. What do you think this is? It seems to be a challenging concept. Everybody understands what trees are, what water is, what buildings are. But when I turn that into the term land cover, we seem to. And then finally, as Rusty mentioned, we have this citizen science challenge called Go on a Trail that is, in one sense, focused here on the Lewis and Clark trail and that science expedition. But we also hope that people will take the opportunity to go out and get to know their local area and go into some places that are harder to get to because they are a trail where pedestrians go and not all the roads and things like that. So that's kind of my quick outline for today. So please add on there if you have any questions or anything else that you would like me to touch on today. Next slide. And so a little bit of an introduction to me. I consider myself to be a remote sensing scientist, but I primarily use the satellite data to help to teach people about the world that we all live in. I've been fortunate to work here at Oregon State University in what we call the eMapper lab, but it's all about mapping out the patterns and processes that are happening on Earth. And satellites give us a really unique perspective to get at that. We have all kinds of great animations that I'll be highlighting today, but you might go and explore our website a little bit more on your own to see some of the data and some of the artifacts that you might be able to use in your teaching or exploration. So, next slide. So for me, I really want people to, I would hope that you can imagine what it would be like. What kind of answers to questions can we solve by working together? And so part of this is all of us actually working together using the same type of tools to be able to collect information that allows us to understand what's happening in one place on the globe and connect it to another place on the globe. So being active participants in the science of mapping, measuring, and crucial. And even though it may feel like what you're seeing today isn't anything unique or special, in fact, it's something that is really hard to recreate tomorrow, or the day after, or the day after that. And so it's really important for us to work together and to be active participants in science, because we all have a stake in it. Next slide. So a quick little overview. I'm excited about the GLOBE program because it does provide over 150 million measurements around the globe. 122 countries are involved in this. And so not only are you helping to understand and to map out your local environment, but you're putting it into this global context that allows us to better understand how what's happening in one place of the world is affected by what's happening in, say, Alaska or in other parts of the world. All right, next slide. And for me, as a remote sensing scientist, somebody who looks at Earth from space, we have this ability, and sometimes it's important to focus on air, water, life, or soil, or a particular data collection piece, right? But we want to, at some point, bring that together to understand Earth as a system. And that is one reason why NASA has so many different satellites orbiting and collecting data, is because they do provide us with all of this type of information. And so even though one person might be really concerned about mosquitoes and mosquito habitat, that same data and that same information can then actually be turned around and used by land managers or people who are trying to make other sort of choices. And so the great thing is we have a common data set and measurements that can be used in many different ways. And that helps to bring us together and have something common that we can talk about. Next slide, please. And so NASA creates all of this information, and they like to do it at global scale. And what is helpful about that is it gives us, again, a consistent data set that allows us to make measurements in one location, say the middle of South Dakota, and then again, be able to see where else in the world is having similar patterns, or might have a pixel that is the same color as another place on Earth. And so NASA and scientists are creating all of this information, but sometimes the data that we have is limited. And that's the big reason why Globe Observer is here, is to help us validate or understand, are we getting these maps right? When somebody makes a snow cover map, is there actually snow cover on the ground? That's really important to know, especially if people are using, say, the snow cover to try to figure out where the water is going to melt. And so on the next slide, one of the great things about what NASA has done is this idea of scale. And so, can we actually see a mosquito from space? Probably not, but we can probably see a lot of the conditions that go into making mosquito habitat, or the possibility that we might find mosquitoes in a certain location. And so I'd like to show you a short little video here that NASA has put together that highlights the way that mosquito habitat scientists are using some of the satellite data from NASA to do this.
And this is really a terrific video that Peder has selected, because we are working with this particular scientist this summer in a coordinated project in Oklahoma.
It's a hot August night in eastern South Dakota, a great night at the county fair. The mosquito that transmits West Nile virus comes out to feed on warm July and August nights like this one, but no one is swatting mosquitoes. In South Dakota, public health officials, scientists, and communities join forces to prevent West Nile disease, and now they're getting some help in space.
West Nile virus is actually a bird virus that gets accidentally transmitted into humans and horses and other mammals. In this area, Culex tarsalis is the primary vector for West Nile virus.
The conditions in parts of South Dakota seem to be particularly good for Culex tarsalis and for the mosquito to come into contact with people.
South Dakota has the highest incidence of West Nile of any state in the country. It's a bird disease, but it can cause acute illness in people. It can put people in the hospital. It's killed 35 people in South Dakota already. We need good predictors of when the conditions might be right for an outbreak of West Nile disease.
Public health officials estimate the risk of humans becoming infected by trapping mosquitoes and testing them for West Nile virus. But it's impossible to get enough data to cover such a large, sparsely populated state. The South Dakota Mosquito Information System is using environmental data from space to close those gaps.
We came up with some new ideas for how to develop an improved system for forecasting West Nile virus, leveraging the information and satellite imagery. The major goal of our project is to develop a dynamic risk mapping approach for West Nile virus and to produce forecasts and risk assessments that are useful to public health officials and can actually be applied to do a better job of disease prevention and mosquito control.
The South Dakota Department of Health provides important data on the location of infected mosquitoes and on human cases to Dr. Wimberly and Dr. Hildreth.
The mosquito data allows us to get a very accurate estimate of disease risk, and the environmental data allows us to extend that over space.
The approach that we're using for this project is really to take the mosquito data, the virus data that we have from the various years, and look at correlations between the years that have a lot of transmission of West Nile versus low transmission, correlating that to environmental data that's coming from the satellite imaging.
We've used a variety of Modus products, and they've been particularly valuable because have also proved to be very useful, particularly for trying to more detailed, finer scale risk mapping.
We're looking for patterns, predictive patterns, much like the weather forecasters are doing.
Temperature has really proved to be the most important variable for West Nile virus in our state. People tend to associate mosquitoes with rainfall and water for breeding sites. But you also have to remember that these mosquitoes are tiny, full-blooded organisms. And as a result, all of the processes associated with mosquitoes are all strongly influenced by temperature. Even the rate of development of the virus inside the mosquito is strongly temperature sensitive, so that generally when it's warmer, a mosquito can transmit the virus more rapidly.
The combination of the disease data, the environmental data, the climatological data is exactly what we need. West Nile is a very complex disease.
What we're working on right now is putting out weekly risk assessment reports, and we combine that with a risk map based on temperature.
We're trying then to help people take precautions during those high transmission years, during those peak transmission time periods.
The information that we're getting from the project are maps of risk factors associated with things that we at the health department really can't track or figure out. Things that have to do with climate, lay of the land, precipitation, what's growing, and they're able to pinpoint potential hotspots across the state of South Dakota. I think this will be absolutely an essential tool in controlling West Nile here in South Dakota.
Our top priority of our program and our mission of our program is the protection of the public health of the citizens of Aberdeen. We run a mosquito control program, and it's an integrated pest management program. I told our community leaders a number of weeks ago when those threat assessments came in that we were shifting our efforts now away from nuisance mosquitoes onto the helix and the virus mosquitoes. We're really excited about that project. We think it's going to be a tremendous help.
This West Nile NASA project is the first real project where I've been involved, where we've seen practical use using our state health department disease data, correlating with the NASA environmental and climatological data to really make some good predictors of a disease that's really hurting and killing people in this state.
Well, thank you so much. I hope that that video does a good job of sort of introducing how NASA is using on-the-ground observations from some mosquito habitat mapper together with the satellite data, especially in places where it's sparsely populated. And that is a location where people don't live is one of the ideal places for remote sensing research and data. Because if you don't have people there, how else are you going to get a measurement? But the interesting thing is what goes right through the middle of South Dakota, the Missouri River and the Lewis and Clark Trail. So this is, one of the interesting things that, ties together what we just saw to kind of this overarching challenge that we have coming up for this summer. So I just kind of want to do a quick poll here. And I'm just kind of curious, based off of what you just saw and maybe your own experience, but where do you think you would find mosquito habitat? Would it be in picture A, picture B, or picture C? Or all of them, or just a couple of them? But put in the chat what you're thinking there. And maybe why. All right, so we're seeing A, B, and C, A and C. Yeah. So I think one thing that people are picking up in terms of, especially picture A and picture C is how green it is. And one of the things that we know about vegetation or photosynthesis or how plants grow, they need water. And so in many cases, what you're sort of picking up on is if there's a green landscape, it probably has some water in it. In contrast to the middle picture, picture B, where you probably have a lot less probability of finding water and finding a habitat that would be conducive to what mosquitoes like to lay their larvae in. And so, but if I was looking for mosquitoes in this, I'd probably go right to those shrubs and look around to see are there mosquitoes or bugs or other things hiding out in that habitat. In the other two, in A or B, it might be a little bit easier to find water or areas that might have mosquito habitat in it. One thing I want to point out is that you might actually find different mosquito area that is forested that might have water pooling in natural ponds and might even have a little bit more of a more intact ecosystem to it, in contrast to agricultural areas, which have different plant communities. They can sometimes get warmer because of the direct sun hitting them. And so what Dr. Wimberly was saying, temperature is a really important part of being able to identify or find mosquitoes. And so even though you might go out to a location and it may look the same in terms of the land cover, the temperature and the climate around that might change. So all of a sudden, it might be a perfect temperature for mosquitoes to actually use ponds or water features in the landscape to lay their eggs. And so this is where it's important to actually go out and monitor these throughout the year, because you might find that in the same habitat or the same land cover, depending on the temperature, you might end up being able to find mosquito habitat. All right. So thank you guys for going through that. And this is basically what we're wanting you to do with the land cover tool, is to go out and when you do use the Globe Observer mobile app to collect your information, it's really neat because if you focus just on the mosquito habitat, you're getting one view of the landscape, right? But if you step back and actually take pictures of the clouds at the same time, that actually might also inform us about the temperature or about the precipitation that is useful. So bundling these things together is really useful from the science point of view. But importantly, this app allows you to submit data and you don't have to actually manage it, but you actually can share your observations. Okay, next slide. So I wanted to just kind of highlight a couple interesting connections between land cover and mosquito habitat that I found. Now, there's a lot of research going on, and so what is happening in one part of the world may not necessarily be exactly what we find in another one, but this gives us a sense for how mosquitoes are actually making use of the landscape or land cover. And I thought it was really interesting. Even though you're in an urban area, right next to that urban area, you might have forests. And in fact, in Argentina, they were finding very different mosquitoes in those two different habitats, in those two different land cover types. And so, that was a recent interesting finding. And so you don't have to travel far to actually start finding different mosquito species in your area. Sometimes it's just a matter of going to a different land cover type. And that was, one of the interesting things that they found in Brazil is that, artificial habitats and temporary groundwater had a lot of variability to it, but these natural plants that held water actually had a lot of the same species in it. So this is where, when you're going out and making samples in the landscape, going to different land cover locations can actually help us to understand how mosquitoes are using the different areas. And then I think it's really important to think about this idea of change, we live in a world where people are making impacts. They are actually choosing to cut down trees. And by actually doing that action, they are changing the landscape, but they are also changing the habitat for different mosquitoes. And I thought this was a really telling statistic that with just a 4% change in forest area in the Amazon, it actually increased malaria incidence by 48%. And so this connection between putting people in the landscape, the age of trees, how we're managing and interacting with our landscape can really change our disease metrics and our susceptibilities to diseases. And so even though what you're seeing today is what it is, just imagine what the world will be like in 10 years. And what information will we want to have in 10 years that can help us to better understand the way that we're changing our land cover on Earth, but then importantly, how does that land cover end up influencing us and our own health? Okay, next slide. So as a land cover scientist, what I am excited about is that when you are using the Mosquito Habitat Mapper, you are already actually identifying the land cover types that are out there. But we're kind of focused them on the hydrology, or kind of the areas that we expect to be wet, right? And so when you actually say or note that you are seeing mosquitoes in a lake or a pond, that is actually a land cover type that we are mapping out. And so we're trying to find all of the lakes or all of the surface water that's out there. And so I've actually started looking at this right here as another way of helping me to know where is water on the landscape. Okay, next slide. So, and what's great is that you can go to the globe visualization system, and I can see what type of land cover or habitats people are finding. And as you can see, I can actually start combining that together with the biosphere, or where the land cover data is stored. And so located data allows us to hopefully have measurements that help us to understand not only where mosquitoes are at, but maybe why they're there. And this is where land cover and even the climate or weather data is really helpful and useful to help us to understand why we're seeing mosquitoes in that location. Next slide. So, and as I mentioned, there is this nice connection where if you record and identify or see a breeding area for mosquitoes, do a land cover observation at that same time. And what we're hoping you'll do with that is help to put that mosquito into a larger context. Because with land cover, we're looking at how the individual trees or the shrubs or the water actually comes together in the landscape. What's the proportion? How much edge is there between where the water body is and where the trees are located? These are all places that mosquitoes really like, is these transitions between the water bodies and the trees, for instance. And so this connection between the two really allows you to document where the mosquitoes are in the landscape. Okay, next slide. And so briefly, when you use the land cover tool, you've done your mosquito habitat observation, you've maybe taken your sample. Well, now if you go in, we have a tutorial that walks you through how to take those photos, and you can get a badge. And the key here is, if you just take photos of the landscape, that's really useful. If you tell us and classify those photos and tell us how many trees there are or how much water there is, that's even more useful. And then finally, if you compare it to the satellite data, like what Dr. Wimberly was showing earlier, that actually is really, really useful, because that helps us to know that the map we made was wrong, or maybe we got it right, all the better. right? But that's where your local knowledge or your place in the landscape can help us know what we're seeing or maybe why we got it wrong. Okay, next slide. So again, kind of walking through, we want you to tell us a little bit about this, and so we have a couple slides that go through and actually tell us the different parts of the land cover that you're seeing in your area. Next one. And for me, a neat thing is you actually end up making your own map. And so if you do this as part of your mosquito habitat mapping, you actually end up making a map of the different land cover types. And where are you finding the mosquitoes? Are you finding them in urban areas, or are you finding them in trees and forested areas? That might help you to get better at your classification of different mosquito species as well, because they tend to like different sort of habitats like that. Okay, next slide. And importantly, you also can go and explore some of the data that NASA has. And as Dr. Wimberly pointed out, surface temperature or temperature is a really important characteristic. And so NASA actually provides this information to you for free. And not only for today, but as you can see in the lower left of the screen, on this site, you can actually go back in time. And so if you actually have collected mosquito habitat data in the past, you can go back and you can look at what is the surface temperature at that time. And was it really warm or was it really cold? And what this allows you to do is to figure out maybe where you want to go sample in the landscape, as well as be able to track the temperature of your local area and how mosquitoes are responding to that. Okay, next slide. And so as we pointed out, we tend to think about precipitation with mosquitoes. And so one way that you can sort of get an idea of how moist is an area or how wet is an area is by the cloud cover. Without cloud cover, you probably don't have a lot of rain coming down or snow or any other sort of precipitation. And the cloud cover can actually also reduce the temperature on the ground. And so again, if you add in that piece to your mosquito habitat mapping, it might help you to better predict, even in your area, when you might see mosquitoes emerge, because we haven't had cloud cover in 4 weeks. Well, that might mean that all the water is warming up enough that the mosquitoes will like that. Okay, next slide. And I think, as we all know, mosquitoes really do need that water to breed in. And mapping out water is actually one of the more challenging things that we can do because it is dynamic. It changes color depending on whether there's minerals in it or soil or ice or all kinds of different things. And so this has been one of the big challenges. And so if you help us to map out where you're seeing water, or, again, when you're identifying mosquito habitat, if you let us know that, we can actually do a better job of mapping out where water is. And I think it's really important. And what I like about this is that, this idea of whether something is water really is this range, going from sometimes there's water, like it just rained and water's on the ground, but then it drains away, all the way to a water body like the Great Lakes, something that's there all the time, right? And there is this spectrum depending on where you are on the landscape at the time that you are out there. And so I want to encourage you to explore this tool that has been developed that gives you the ability to see what is the water seasonality in my area. And again, you can kind of go back in time with this tool to do that. Okay, next slide. And finally, as was kind of mentioned, this connection between natural holes or crevices where water can accumulate tends to be in the tree areas. And so helping us to identify the tree cover, where you're finding trees, And especially those edges where you go from tree cover to, say, water body, or tree cover to buildings, or tree cover to grassland. That actually tends to be a really good place where mosquitoes might leave and interact with people a little bit more. So I bring this up because this is an example of the type of work and data that scientists are trying to do. We're trying to find out where that connection to just a little bit of deforestation to all of a sudden having 50% increase in disease is astounding, right? So that's the connection that we're trying to make, and you can really help us out with that. Okay, next slide. And as Rusty mentioned about 20 minutes ago or 30 minutes ago, when she was talking, is this idea of transitions that even though land cover might seem like it's one of these things that isn't changing, it's not really exciting. In fact, it is something that is changing on a seasonal basis as well as a yearly basis or a decadal basis. And what we find here, this is a map that our lab has put together, trying to predict what we think the land cover is across the continental United States. Now, we're extending this out to globally, but this is the type of thing that the Globe Observer land cover tool is made to support. Help us know whether we got this right, because scientists like Dr. Wimberly actually use this product to help him understand where the agricultural lands are, or where these edges are between forest and where people live. And so if we don't get this map right, then what he's doing will be wrong. And then his early warning system won't alert people to the true conditions that are out there. And we want to try to minimize that. Okay, next slide. And so, for me, the important thing is again, even though scientists like to make these maps that have these hard edges that seem to make it feel like here's the edge of the edge of the urban area, or here's the edge of grassland, or here's where all the forest is. In fact, we know that there are trees in areas where people live or in urban landscapes. And so that's the important thing, is that these maps sometimes hide water or the mosquito habitat that we're really trying to get after. Okay, next slide. And so, as we start looking at, the satellite view, what we usually see, which is this red, green, blue view of the world, we look at that and we might be able to start quickly seeing where we might want to go look at the landscape and look for mosquito habitat, right? Trying to identify water is one of those. But the satellite data, sometimes it's like, I can't really make out what's water. It's all kind of dark, right? So if you go to the next slide, one of the things that we can do is this, again, is a land cover map that allows us to take what can be hard to interpret or understand and turn it into something that's a little bit easier. So we can see the red areas are the urban areas where people are living. And then we have the blue areas, which is the water that's really obvious. And what I want you to focus on here in towards the very end of my talk here is at the bottom. If you follow the river, or sort of the blue speckles that go across in the lower part of the screen, what you actually see is that it's not a continuous blue line going across. And that's because the river gets narrow in certain places and you have trees that overhang. And so that's an area that is really confusing to see from above. But if you were there on the ground and took some pictures, it would help us to know why is that river not a continuous line? So that's a really, for me, a really good example of how the scale of the satellite data can end up influencing the maps that we make. Okay, next slide. So we've the idea of how forests or trees are on the landscape is really kind of interesting. And to me, I want to point out this interesting bend of the river right in the middle, and where you have this interesting growth of trees. That change in the river is kind of what Rusty was talking about, how the Missouri River has changed over time. And what used to be maybe a nice bend in the river has sort of been contained a little bit more. And so, you know, these are the kinds of changes that are happening out there that we want to capture, because they really do change where mosquitoes are on the landscape. Okay, next slide. So I just wanted to pop this up because of the different colors of water that are out there. That sometimes you're seeing blue water, sometimes you're seeing brown water. And having a satellite view like this is a great way to just first figure out where might you actually see mosquito habitat in your location by pulling up something like Google Earth or a tool like this Global Forest Watch does. Okay, next slide. And so, you know, I will end here, you know, with our Go on a Trail challenge with the Lewis and Clark National Historic Trail. And like what was mentioned by Rusty is those journals really do allow us to go back in time and to compare what we see today to what was there. Now, you can do the same sort of thing with your activities, where even just looking back a year ago can be a good contrast, let alone 200 years. But it all starts with making that observation. And if we don't have that observation, it makes it really hard to do that comparison. So on the next slide is you know, what we'll be doing starting this weekend, starting June 1st and going through September 2nd. You have the opportunity to really help out scientists, as we've been talking about, by either using the Mosquito Habitat Mapper or in particular using the land cover tool to help us get at some of this larger habitat that's out there and the changes. And again, even though, you know, we're kind of focused on this, you know, we encourage you to go out and go on a trail in your local area and make some observations for science. Okay, next slide. And the big reason why I want to say that is because look at where we have this missing data. You know, we don't have a consistent coverage yet. And this is why, you know, we need a community to be built to really get after filling in these gaps and these holes. So that's what we're hoping we'll do this summer. Okay, my final slide. Go one more. Okay, so I would like you, I invite you to join the community, go out and collect the data and connect our planet together. And by working together, we can solve some of these problems and we can better understand the changing world that we live in. Thanks for your time. I really appreciate it.
Hey, thank you so much, Peder. That was so interesting. And lots of really interesting questions from everybody that was listening in the chat. I think we have 5 more minutes, and we were hoping that Cassie would be able to introduce the new group making tool, the team making tool. Do you think you have time to do that, Cassie, before we sign off?
I'll certainly try.
Great, because this is something that's just been developed. And when we've been working with some of our partners at libraries, museums, 4-H, things like that, people are real interested in, you know, we're all collecting data, but wouldn't it be nice to know what part of that data was my group? You know, what's our contribution? And this is a tool that's going to let you do that.
Right. And so what I did was I put together a little kind of a how-to video. Oh, here's Peder's information. I will upload the webinar and the PowerPoint. And so putting together a team, it's called a team. And so the first thing you need to have is a Globe account. So if you have it on your app, you already have your email, that's your login and your password to get in. And so I created just a little how-to video to kind of step you through it. So up in the right-hand corner, you sign in with your email address and password. And under community, you'll choose Globe Teams. And a team is any group of people. It could be from your library, it could be from science museum, classroom, but whoever creates the email address You give it a team name in English that's at least 4 characters long. If it turns red, you've got to redo it. Provide a state or territory. The city and zip code are optional. And then click continue, verify you're not a robot, and you'll be sent an email with a referral code into it, which I show you in a bit. But to go back and to join a team, so the creator is the manager and owner of the team. And so they're going to show people how they can join the team that they've just created. They're in alphabetical order, and your team can be one of 3 different categories. And I'll show you those in just a second here. So the team I just made is called IGES. And this is, I have 1 member, that's myself, and I'm clicking on Manage the Team. And you can choose organization type public for anybody. Private requires a referral code. So if it's a group of students, for example, you might want to just keep it kind of individual. Or you can have it totally private where nobody who's new to Globe can join, only existing members. And then when you click on members, you'll see all the people who belong to your team. I just paused it for a second there. So I just created it. I am the only person in this particular team. But what you'll find is a referral code. And that is located right here. And it's for the team manager, to see. So this is what you want to hand out to people is your referral code. And that's how you'll keep track of everybody. Next, I have just kind of a copy of the email with a referral code that you'll get to it. And here's the type of information you can get. So you have people in your organization or your group. You can see where they've been collecting data, and you can see what type of data they've collected for you. So whether it's mosquito data or atmospheric or cloud data, and if you click on any one of them, it'll automatically launch the visualization tool, and you can see what kind of photos or data that particular contributor to your team has uploaded. As manager of the team, you do have access to the email, so you want to be very careful about how you're distributing and sharing the information. Now, many of you are going to be in a facility where you'll have created this team already, and you're having people using their app or smartphone. And so I have another slide to kind of show you how that works. And thanks to Kristen Weaver for this one. But if you're using your app, and if somebody new, they can create their account, click country, and then this is where they type in the referral code, and then they create their account online. They have to check their email to get the password to log in, and the app remembers it. You don't have to put that in each and every time. Now there's another way that you can do it, and that's already if you have the app account, how you can do it. Also your email address, password, and you can do this all from your smartphone, entering in the referral code again. And we made this for a group I did a presentation for last week. That's why the little Omer guy is there. But it's pretty awesome. You can have lots of people in your group and see where you're making an impact and how far I reach, and zooming in to the locations and kind of filling in that data map. And that's it, Rusty.
Okay, that was absolutely great. I think we're over time, so I think we should just end at this point. And these are just a few other resources that you might be interested in looking at. You can find them at the when you look at the archived webinar. There is a wonderful video that Peder has given us that we're going to open our next webinar with, because the next webinar we're going to be talking about some free mapping tools that you can use. And I think that the video that his unit put together about using remotely sensed data is going to be a fantastic introduction to Dr. Becky Boger's talk. So please be sure to be here for next month's webinar. We really look forward to seeing you. And if you have any questions, you can contact us on the next slide. You'll find our contact information.
And quickly to answer your question about posting a link. Tomorrow, I think you'll get a thank you email and letting you know where the archive is, that it's on the Globe website under Mission Mosquito.
Great. So here are I'm really having trouble talking today. I have jet lag, I'm sorry. But you can see with Rusty and Cassie, there's an underscore between our first and last names. We really should have those nice dots like Dorian and Peder because it's a lot clearer. But if you have any questions, the archived webinar, or if you want to jot these down now, let us know. Otherwise, you can also find us and contact us on the website. So we want to thank you so much for your all of your Rusty needs sleep. For all of your attention today. And once again, thank you so much, Peder, for a really exciting and interesting talk. Really enjoyed it. It makes me want to go out and collect land cover and mosquitoes at the same time. And I'm hoping that some people will have the same enthusiasm after seeing this. So thank you so much.
All right. Thank you all very much, too.
Yeah.
I'll end the meeting now.
Okay. Thank you.